Welcome. Today is day 4 of the Pre MBA Preparation series on this channel. In this series, I learn difficult MBA concepts, make notes on them, and share them with you every single day till I join my BSchool. Now, why am I doing this? I'm doing this because I thought that we are social animals, and if we can see each other that we are preparing this and we are in this together, you might find the little bit of extra punch and motivation that you need to prepare before MBA. And if you're on the same boat as me, join me in this journey, subscribe, and let's prepare for MBA together. So, if you've not been following, we've already completed 3.5 lectures of this particular IIM Ahmedabad statistics course with the name Analytics for Business Problem Solving. There's already day 1, day 2, and day 3 that has been uploaded on this channel. If you've not been following, go ahead and do that first and then come to day 4, which is today. So, this is for people who are following. The first thing that we're going to start today is measures of relative location and detecting outliers. So this has 4 subparts to it that we'll study. The first thing is z-scores, second is Chebyshev's theorem, third is empirical rule, and the fourth is detecting outliers. I have my notes in front of me and these notes are also there on the screen. Also, if you want access to these notes, it's in the description as well. Okay. Let's start with z-score. What's a z-score? The z-score denotes the number of standard deviation points that a data value xi is from the mean, where I can range from 1 to n. That is n number of data values, right? Now, what does this basically mean? It basically means that we are trying to find the distance between the mean and any particular data point on that data set in terms of the standard deviation. So, for example, we consider standard deviation as 2, and if 2 is the standard deviation, we want to see what multiple of 2 is the distance between the mean and that particular data point. Makes sense? So that is the z-score. What's the formula for it? Zi is equals to xi, that is that particular element, minus x bar, which is the mean, divided by s, which is the standard deviation. The next point is a data value less than sample mean will have a z-score less than 0. Makes sense, because if the data value is less than the mean, then the subtraction will become negative and the z-score will be less than 0. It should be vice versa as well. Yes. So data value greater than the sample mean will have a z-score greater than 0, and if the data value is equal to the mean, then it becomes 0. Subtraction becomes 0, right? Makes sense. The next main point is Chebyshev's theorem. It's a difficult word to pronounce. Anyways, so this is a theorem which is a conservative theorem, but it's a true theorem. Let's see the theorem first. It's at least 1 minus 1 by k squared of the items in any data set will be within k standard deviations of the mean, where k is any value greater than 1. What do we mean by this? We are saying that at least this ratio of items, that is 1 minus 1 by k squared, ratio of the items will be within k standard deviation. So as I said, multiple of the standard deviations, we're looking at the distance, so will be within k standard deviations. Let's look at the few examples over here. Let's consider k to be 2. For example, if k is 2, then the formula becomes 1 minus 1 by 2 squared. If k is 2, that becomes 1 minus 1 by 4, that is 3 by 4. 3 by 4 means 75%. So the first point here is at least 75% of the items must be within k equals to 2 standard deviations of the mean. Makes sense now? Second is at least 89% of the items must be within k equals to 3 standard deviations of the mean. And the third point is at least 95% of the items must be within k equal to 4 standard deviations of the mean. Now this makes sense, right? Now, what's the derivation of this? Professor Tathagat, the person who is teaching us, he said that there's a proper derivation for this, but they don't want to go into it because what we need to understand essentially is how to use this particular tool and theorem. We don't need to go into derivation. If somebody is a mathematics buff, then you can go into this derivation as well. I think I'll go into it myself in my free time as well. Anyways, let's go to the next rule, which is the empirical rule, which is a much more popular rule. The empirical rule is a non-conservative tool or a rule which is more accurate. So this particular rule gives more accurate understanding or answer than the Chebyshev's theorem, but it is false. The Chebyshev's theorem is always true, but empirical rule can give us a false answer, but it will be close to the actual answer. Makes sense? Chebyshev's theorem generally is very far away from the actual answer, but it's always true. So, what am I trying to say over here? For example, I say that the number 3 is less than 5. It is true, right? But 3 is very far away from 5. But if we say that I'm talking about a number which is 4.999. Now 4.999 is not the actual answer which we want, which is 5. But it's very close to 5. So it's more accurate, but it's false. But if we say that the Chebyshev theorem is saying that 3 is less than 5, it is true, but it's very far away from the actual answer. Now, makes sense? Now, what's the empirical rule? It is, if a particular data set is normally distributed, then the empirical rule states that 68% of the data are less than one standard deviation away from the mean, 95% of the data are less than two standard deviations away from the mean, and 99.7% data are within three standard deviations away from the mean. So generally, the last point we consider it as 100% in actual use cases, but this is what it basically means. This is the empirical rule. Now, again, don't ask me how and where this is derived from. It's just there, and they're saying to us, they're telling us to use it for our for whatever use that we have. So we'll not go into the derivations right now. Maybe again, if you're a mathematics buff, look at it in your own free time. Let's look at this note. This rule also helps us to detect outliers. We can generally expect all values. Now, this is an important point. We generally expect that all the values in a data set are to be within plus minus three standard deviations from the mean. So this is a basic rule that the empirical rule states. As I said, 99.7% we consider as 100%. So within three plus minus three standard deviations, all the data sets should be included. Now, if a particular value in the data set goes beyond this limit, we say it's an outlier. That's how we detect outliers. All right. Now, why does something become an outlier? Why do we say that something is an outlier? There are three main reasons it can be an outlier. The first one is it is incorrectly recorded data value. If it's incorrectly recorded, it can be an outlier. Second one is it is incorrectly added to the data set. So it was not supposed to be there. It was not even recorded. It's just been added incorrectly. So that's a problem. The third is correctly recorded data value that belongs to a particular data set. So correctly recorded data value that belongs to a particular data set. This is the one that we are concerned with. So in the off case that we are actually recording it and it's a correct value and that it's an outlier, then we need to find out what's the reason behind that outlier. So for example, there was an exam that is taking place in your particular B school or in our B school, and what happens is there's a test being taken, and inside that test most of the students, let's say all 99, there are total 100 students, 99 students get 20 marks in the test out of 100, and one student gets 99 out of 100. Now that's an outlier, right? But the problem over here is he is actually a recorded outlier, which is he's a real outlier. Now, what do we do in this case? What we say is the first thing is the total, or the all of the people who got 20 marks in the test, they are what represent, they represent together what we call the mean. We can't say that the outlier represents the mean. We can't say that because it's just an outlier. It's not the norm of what's happening. But what's also important over here to recognize is that since there's a proper outlier, a legit outlier, that is the particular value that gives us the most information. That is, we want to probe into the reason why did that become an outlier. So in the market, for example, all businesses are failing, and we want to look at this particular one business that is succeeding. So why are they succeeding? What's the reason that they're succeeding? We must look at that, and that gives us the most information. Do we get a lot of information from what's already in the norm, what's already common? No, we already know that. But what we get more information from is the outlier. So that's what they are talking about. Now let's go to the next point, which is data summarization using 5 numbers summary. So this is a particular method of data summarization which is very, very popular, and it has 5 parts to it, which is smallest value, first quartile, median, third quartile, and largest value. Now first quartile is 25%, as you know, median is 50%, third quartile is 75%, largest value is the 100%, that is the largest one, and the smallest value is at the 0%. So if we draw a particular progress graph, so how much at what point is each of these data values, we can say that the first one is at the starting point, last one at the ending point, and the other ones at the 25%, 50%, and 75% respectively. Makes sense. The next thing is, how do we basically represent this 5 number summary? We represent this using a box plot. That is how it is used. Now if you're a stock market trader, you would have seen box plots a lot of times. Now let's understand what is really a box plot and what do we learn from it. So this is one representation that you can see on the screen of the box plot, where we can see that there's this box. In the middle of that box there's a line, and that line is what represents the median. Now the start of the line is the 25%, that is the first quartile. End of the line is 75%. Then you will see there's a dashed line that goes to the left and the right of the box. These lines are called whiskers. Okay, these lines are called whiskers. The line on the left side ends at the lower limit, or LL, and the line on the right side ends at the upper limit, or UL. What are the values of these? We'll look at it later, but you can also see that there are two other points of the left side. Other than that whisker line, there are two other points. I've already named them as outliers. So these whiskers are basically the limits of till what extent that the data set goes to on the number line or on the data set line on both sides. And if there are points which are outliers, they go beyond the limit. Now what are these? What is the formula for this lower limit and upper limit? You can see over here. Lower limit is basically quartile 1 minus 1.5 times the interquartile range. Interquartile range is basically 75% minus 25%. All right. And the upper limit is quartile 3 plus 1.5 times interquartile range. Now look at this. This is really interesting. The box plot to graph. Just remember this. This is how it looks. It's very easy to understand as well. If the box plot looks like the first point, then the graph is normally distributed and not skewed. If the box plot looks like the second point, the graph is a bit skewed to the right side. Third point, skewed to the left side. Fourth point, it's almost like a hyperbola. It's the opposite of what it would look like in a oppositely turned quadratic equation or a negative quadratic equation. That is how it looks. If you want to understand why it looks, just look at this graph and try to apply your common sense into this. You will understand why these graphs are like this. It's very, very simple. Now let's go to lecture 5. It's that short. You can see this. This is so short. It's a 1 hour lecture. The reason it is like this is because in the whole lecture they discuss a particular case, and I particularly feel that these cases we learn a lot of cases when we go to our B school. Right now we don't need to learn a lot of cases in this manner when we are making notes. We can learn cases separately, but while we're making notes, it's important that we get the theory right before going there. So there it becomes easy for us, right? Let's see. Lecture 5 is how to connect business problems to analytics. I don't see the way that they have structured this particular lecture properly, because this topic, that how to connect business problems to analytics, has not only been discussed in this particular lecture, but still whatever conclusions we have, I've written over here. The first point is steps in problem solving. At the high level, the steps in problem solving is understanding the situation, finding the complication, and then finding out the resolution to that particular complication. The most important for us over here is to understand the situation or the context that the business is set in. That is, the more you understand about the business, the better you understand their problems, the better solutions you come up with as a consultant, for example. The second point is the goal is to ask the right questions so we can get the right data or info that directly impacts the final resolution decision that the main decision maker makes. All right, so that is lecture 5 for you. Lecture 4 has been finished. Lecture 5 has been finished, and now I think we have finished 5 lectures of this course, and we are done with 5 lectures. So that means there's going to be a change of gears again. So I've gone through the course. I was looking at the different topics that are there in this course, and I saw that the first 5 topics kind of covers all the basic statistics that we need to know before joining MBA. Now the other parts to this lecture is or this particular course is about implementation of this in a much more deeper sense. I personally don't feel that we need to go inside it. I'll tell you the reason. It's not half-assing it. I'll tell you the reason. Now we are left with almost I think around 30 days before we join our B schools, and it's very, very less time. 30 days is very less time. I don't know. Some people have 45 days, but it's still very less time. So in lieu of the time that we are left with, we need to cover all the important topics that we have, so that we at least have a base understanding of a lot of topics. We can't just stick to one topic and try to complete it and just ignore other topics, right? Which we don't understand. So the next plan of action will be, we have covered 5 lectures of this particular course. We'll put a halt to this. We have learned a lot. You already have the notes of this, it's down in the description. Now we will switch gears and go to the next thing, which is Excel. So I'm very interested and very excited to learn Excel from tomorrow onwards. And I'll also share whatever I learn as I'm doing so far through these videos. Tune in tomorrow. Let's see you tomorrow. Let's work and prepare tomorrow again. Namaskaram. Bye bye.